Okay, so we're gonna go ahead and continue scientific notation. Take out your notebooks if you haven't done so already. Yesterday we did operations with scientific notations and we multiplied. Today, I'll go to a new page. Today it's dividing. Dividing. I'm gonna write down the page number before I forget. Page 10. So we're gonna divide in scientific notation. Okay. I want to start off with a quick example. So here's an example. And the example, I'm going to just write out the problem. And on the Delta Math, they're going to be written this way. So this is one of the reasons I want to do it in this format. So it's going to say the quotient of 1.485 times 10 to the 6th power, and I use a little and symbol there, 4.95 times 10 to the second in scientific notation. So I just put in SN. So go ahead and write that down. The quotient of 1.485 times 10 to the sixth and 4.95 times 10 to the second in scientific notation. Okay. So let's answer this. The first thing I'm going to do, and I suggest you do the same thing, let's set this up as a division problem kind of along the lines of algebra. So I'm going to write it this format. The first number is the numerator in a fraction, 1.485 times 10 to the sixth. And the second number will be the denominator. I'm going to write that one. Now, what we're going to do is this is going to be kind of our barrier. On the one hand, we want to divide these numbers. Okay, so let's get the answer to that. 1.485 divided by 4.95. And that gives me 0.3. So dividing the coefficients gets me 0.3. Okay. Now, the second part comes from dividing the powers. And remember what's going to happen if we divide powers with the same base? Got to subtract those exponents. So the math problem I get here is the first number, which is 6, minus the second number, which is 2. And that's going to give me 4. So what that tells me is 10 to the 6th divided by 10 squared is 10 to the 4th. So now our answer is 0.3 times 10 to the 4th. Okay. Close it, close it. Okay. So we got to do this fix though. Got to go that way 1. So that means you subtract 1. Move 1 further to the left on the number line. So our final answer is what? Won't be 0.3. It's going to be 3 times 10 to the third, or 3,000. If we needed to convert this into just a standard number, it's 3,000. But we'll leave it that way because it asks for scientific notation. Okay. Any questions? All right. So let's do a few more. So we're going to find the quotient and write the answer in scientific notation. Find the quotient, and we're going to express that in Sn. I'm going to just write them in this format. I won't be writing the sentence, the quotient of. In your Delta Math assignment, every problem you're going to see is going to be written this way, but you want to set it up as a fraction like I just did. Okay? So this is number 1. Let's do 8.8 times 10 squared over 8 times 10 to the 7th. Okay? So this is what we're going to be dividing. So let's go ahead and get right to it. So the first thing we should do is divide coefficients. 8.8, divide that by 8. Oh, that's easy, and actually a nice little answer. It's 1.1. Didn't even need a calculator for that. Where it's going to get a little interesting, though, is here. Help me out, guys. What's going to be the subtraction problem I got to work out to figure out the power of 10? 2 minus 7. And 2 minus 7 is negative 5. We're taking away more than what we have. So it's going to be 1.1 times 10 to the negative 5 power. Okay? And that one's already in scientific notation. Nothing else left to do. We're good with that answer. Okay, sometimes that happens. Okay, let's try another one. Number 2. 2.53 times 10 to the times 10 to the 9th divided by 2.7 times 10 to the negative 2. Okay. Everybody got that? Okay, same thing as before. We're going to break it up into 2 math problems, divide the quotients, and then we'll subtract the exponents. Or divide the coefficients. So let's do that. Let's see. 2.53 divided by 2.7. And I get, oh, I get a repeating decimal. Okay, that'll happen. So I get 0.9, then 370 repeating. Okay, yeah, it's 370, 370, 370. So that part's repeating. Now let's do the subtraction here. What if I have 9 on top, -2 on the bottom, what's the subtraction problem I want to set up? Yeah, it's the 9. Think of this bar as a subtraction, and then the second number, -2. 9 minus -2. Okay? So 9 minus -2, yes, it's 11. And anyone want to see how it's 11? You can change every subtraction problem to an addition problem. I call it keep change opposite. Do you remember that? You keep the first number, it stays 9. You change the subtraction to addition. And the number behind the subtraction, you flip its sign. It's opposite. You want its opposite. So that becomes +2. So it's 11. So it's 0.937 repeating times 10 to the 11th. Okay. But we're not quite out of the woods yet. We got to fix this. So one more fix. Move that decimal place once to the right. Yes. You can do it every time, but basically, anytime I see a negative inside my subtraction problem, I usually do it. Like here, I didn't see a negative. I didn't have to do it. But if I see a negative either for the first number or for the second number, I do keep change opposite. Okay? All right. So let's write down the final answer. If I move it once to the right, what do I have to do to the exponent? -1. Okay, so that's going to be 9.370 repeat times 10 to the 11 minus 1, so that's 10th power. Just barely fit it in there. So 9.370 repeat. The 0 repeats too, I just did shit. Times 10 to the 10th. Okay? All right. We'll do a couple more. I want to get all those possibilities with negatives, basically. So number 3, let's take a look at this. 3.243 times 10 to the -8 power divided by 7.05 times 10 to the -2. Now, before we do anything, take a look at the number. Take a look at the coefficients. We're dividing 3 something by 7 something. Is that going to give you a number larger than 1 or smaller than 1? Smaller. So we're probably going to have to do an adjustment like we had here. and number 2. Well, let's just go ahead and do that division. 3.243 divided by 7.05. At least you get a nice number, 0.46. So let's write that down. 0.46, and we expected it to be smaller than 1. And okay, here comes the part where we have to look at our exponents. And let's set up our subtraction. Let's see, we got -8 first. You always put a minus sign. And then the number we're subtracting from -8 is -2. So my question to you is, should we do keep change opposite? Yeah. Anytime you see a negative playing around in those numbers, switch it. So -8, keep it. Minus sign, change it to plus. And the -2, you want its opposite, which is +2. So now we have -8 plus 2, which is -6. Okay? So all of that basically tells us that this is times 10 to the -6 power. Okay? Any questions? Okay, let's do a fix. We got to do this fix. We're going to go once to the left, once to the right. So we subtract 1. Just think about this. You're moving further down the number line to the left. So what's to the left of -6? -7. So this is going to be 4.6 times 10 to the -7. And that is our answer. Any questions? All right. Let's do a couple of word problems. So if you guys are ready, we'll do that. Okay. All right. So the word problems that usually deal with scientific notation division usually involve one of two things. Well, they involve dividing, and some situations is how much larger one thing is to another. Okay, so like, say I tell you that Joe here has $25, and I have $5. How much more or larger is his amount of money to mine? How many times bigger is his amount of money than mine? 5 times bigger, right? How did we figure out that it's 5 times more? With 25 and 5. You divide it. So when they ask you how many times bigger one thing is to another, you're setting up a ratio. The bigger number by the smaller number. Okay? That's one thing that we do. And the other thing deals with traveling, the speed of something and its distance. So let's do a question that involves how many times bigger one thing is to another. Again, we're going to do some science. Okay? So here's our first problem. Say we have an animal cell, and it has a diameter of 9.97 times 10 to the negative 3 centimeters. Okay, so that's the diameter, the distance across an animal cell that we're looking at. Then we're going to compare it to a plant cell. And it has a diameter of 4.2 times 10 to the negative 4, which is actually smaller, centimeters. Okay, so I'll let you write those numbers down. And the question that we're going to answer is, how many times larger is the animal cell to the plant cell? I'm just going to say how much larger. Here's the catch. Answer in standard form to the nearest tenth. I'm just going to highlight that because that's pretty important. We're answering in standard form to the nearest tenth. Normally, we've been spitting out answers in scientific notation, and now we're going to have to convert that SN number to just a regular old number. Okay? All right. Well, let's do this. So, first thing we're going to do is set up our division. We got the larger cell, which is the animal cell. And we're going to compare that to the plant cell. So we're going to set up that ratio. So 9.97 times 10 to the negative 3. And then divide that by 4.2 times 10 to the negative 4. Okay. And let's go ahead and do that dividing. 9.97 divided by 4.2. And I get 2.3738. Ooh, I got a bunch of digits. But fortunately, I know I'm going to round this. So I'm going to just go like 4 digits in. 3738. So I'm going to say this is 2.3738. And I'll cut it off there. But now I also have to figure out the my exponent. So let's do that math problem. I want negative 3 take away -4. -3 minus -4, right? Let's change that to an addition problem. -3 minus -4 becomes -3 plus what? 4. -3 plus 4 is just 1. Okay. So this is 2.3738 times 10 to the 1. So now we want to write this as a standard number. We just want this like a regular old number. Okay? So how do I unpack this? I want to get rid of the times 10 to the 1. You remember what I do? I got to move that decimal, make it bigger. How many times do I move that decimal? 1 time. Take the fact you got 1 and it goes in 1 more. So this is what I'm going to have. 23.738. But wait a minute. I have to round this number to the nearest 10th. What number is in the 10th place? The 7 here. So the rounding number I got to look at is 3. Does 3 tell me to round up the 7 to an 8 or leave it as a 7? So my final answer is 23.7 times larger. So the animal cell is 23.7 times larger than the what is it? Animal cell. Plant cell, sorry. That is our answer. Okay. All right. So we'll do one more word problem. Number 2. Okay, so number 2, put this in here. Number 2 is the distance from Jupiter to Mercury. Okay, here we go. So now we have some astronomy going on. The distance from Jupiter to Mercury is 7.201 times 10 to the 8th kilometers. Yeah. It's like driving to San Diego. Okay, here's the question. How long, so it's asking for time, how long would it take a rocket traveling 2.88 times 10 to the 4th, 2.88 times 10 to the fourth kilometers per hour. What is kilometers per hour? What is that telling you? How fast it's going. So yeah, its speed. You'll be doing more of this in science class this year, I'm sure. Um, so how long would it take a rocket traveling 2.88 times 10 to the fourth kilometers per hour to travel from Jupiter to Mercury? To travel from Jupiter to Mercury. Uh, and it's going to be one of those where we want a standard number, round to the nearest whole number. Okay, so go ahead and write that down. So I'm going to give you a little bit of background science. Okay, so whenever you're talking about traveling any distance, anywhere, a typical formula is rate times time equals distance. Okay, have you ever heard of that before? Rate, which is how fast you're going, multiplied by the time it takes you to travel there, will tell you the distance you traveled. So if you were going 60 miles an hour for 2 hours, that means you went 120 miles because 60 times 2 is 120. Okay? So that's a basic idea. Now, what we're asked to find, let's see, they give us, what do they give us? They tell us 7.201 times 10 to the 8th kilometers. Kilometers, is that a rate, a time, or a distance? That's a distance. Okay. And then they also give us 2.88 times 10 to the fourth kilometers per hour. And Enrique already told us that's a speed, which is a rate. And they asked us, what did they ask? How long would it take? If they ask how long would it take, that's asking for, if someone says, how long is it going to take to finish these notes, which seem to go on forever? Oh, about 2 hours. So when they ask for how long, what are we asking? Time. Okay. So we want a time. So we want to convert this little doohickey into a situation where we figure out time. Here's what you do. You divide both sides by rate. Cancel them here. And what do I have left on this side? Time. So basically what I have to do is take the time, to find the time rather, I want the distance divided by the rate. So it's division. So I'm going to take my distance and start with that. So I'm going to take my distance, 7.201 times 10 to the 8th. 7.201 times 10 to the 8th divided by the time, 2.88 times 10 to the 4th, and divide them. And that should give us our answer. Okay, so I got the distance divided by the rate, and let's divide. Okay, so we're going to divide 7.201 divided by 2.88, and I get some pretty big number. 7.201 times 2.80. Okay, and so I'm going to do the same thing. Give it about 4 digits and then cut it off. So 1, 2, 3, 4. So I'm going to cut it off after the 3. So 2.5003, 2.5003, and then got to do the subtraction part, which is 8 take away 4, which is 4. So that's times 10 to the 4th. Ooh, it worked out perfectly. So there we go. But that's not an answer in standard form. We got to convert this. How many times do we got to move the decimal? 4 times. So we're going to push the decimal 4 times to the right. 1, 2, 3, 4. So our final answer is 25003. So 25,003 hours. Since our units were in hours, it's going to take that many hours to go from Mercury to, actually from Jupiter to Mercury. Which is the planet that's really hot? Is it Mercury or Venus? Huh? Yeah, I bet. Okay. All right.